right, so we're going to do volumes of spheres, and here is the formula we are going to use. They have a proof, or we have, I can show you where they came up with this formula, but I'd rather just go ahead and get to.
368 proof for 2 plus 2 equals 1 plus 1 equals 2.
I'm sure there is. There's a lot of stuff. All right, so here we go. There's that volume formula. That volume equals 4/3 pi r cubed. That is going to be the formula we use for spheres. All right, so 4/3 pi r cubed is our formula for a volume of a sphere. Now, the only thing about those sheets that they're going to give you in the EOC, it will not label what that will find. So you're going to see volume equals this. You're going to see volume equals big B times H. They're not going to tell you what those formulas are for. You're going to have to recognize, oh, this is the volume formula that I need for this sphere.
Anyone who knows pi.
That should help us out. Yes, I agree. Seeing the
being cubed.
Yep, I agree. That's good ways to help yourself remember it. All right, so the other thing we're going to need is surface area for a sphere. And the surface area for a sphere is going to be 4 pi r squared. And then finally, volume of, do you guys know what a half of a sphere is called? Half of a sphere. So like half of a circle is a semicircle. It's not a semisphere. It's a word that you have heard before. So you have the Earth, correct? Is the Earth broken up into 2 sections?
Oh, hemisphere.
Yeah, the northern hemisphere, right? And the southern hemisphere. Those are half the Earth, right? So hemisphere is half a sphere. And that formula is 2/3 pi r cubed. What are you really doing to this formula that's up here? Yeah, you're just dividing it by 2. So these are the 3 formulas we are going to use today. First question is going to tell you that we have a sphere, and the drama club would like to make this foam sphere and hang it above the stage, but they need to cover it with a metallic fabric. What is the minimum number of square meters of fabric that the club needs to buy? So we've got a sphere. So that tries to show that it's a 3D. So there's a sphere, and it tells us that the volume of that sphere is 1.8 meters cubed. If they're going to cover that, what is that called when you cover something? That's the surface area. So we're going to need to find the surface area of this sphere. Well, what was the formula I just gave you for surface area? 4 times pi what? By the way, this formula is not on that paper. You have to know that one. It is not on the paper. All right.
Did you know the amount of water on Earth is actually very disproportionate? If you were to use a regular globe and use all the water on Earth and put it on that globe, it'd only be 18 milliliters. The water on Earth is kind of small.
Yeah. All right. So what do we need? What piece of information do we need in order to find the surface area? What's the variable we need? The radius. Right? I need the r, and then I just square the r times by pi times by 4. I got the surface area. Did they give me the r over here? What did they give me instead? Do I know how to use a volume formula and work backwards and solve for the radius? I hope so. 0.18 equals, what was the volume formula for a sphere? 4/3 pi r cubed.
So,
The way I would do this is I would undo dividing by 3 by timesing by 3. That would cancel those two out.
3 pi r. We're solving for r?
Yeah, we're solving for r. So I times by 3, so the 3 on the bottom canceled out with the 3 over here. So then I do 1.8 times 3, and I get 5.4. And that equals what? What's left over there, though?
R cubed. You have to.
Something else too, Peyton.
I.
So I canceled out the 3. What's still above the 3? So 4 pi r cubed is left over. How do I undo timesing by 4 pi? So I'm going to divide by 4 pi. Divide by 4 pi. So in my calculator, I'm going to hit divide and then parentheses 4 times shift pi, close parentheses. Bless you. When you close the parentheses, you're going to get 12.56. I'll do it again. 5.4 divided by, in parentheses, 4 times shift pi. Close parentheses. When you close parentheses, the 4 pi, now in your calculator, you're going to see a 12.566 repeating.
12.566.
Yeah, I didn't mean repeating, but yeah, sorry.
Showing on gibberish.
12.566, blah, blah, blah. Yes? You see right here? Right there. Parentheses are right there. And you're going to hit 4 times pi. You have to hit shift to get to pi. Did you figure it out? Divided by, and then parentheses, 4 times, and then you have to hit shift and the EXP because that's the pi button on the calculator. And now close the parentheses. When you close the parentheses, you're going to get this number in your calculator. It's on the board, 12.566. Okay, that's not your answer. That is the 4 times the pi. The calculator did the parentheses part so far, which is the 4 times pi. What has it not done yet? The 5.4 divided by that number. So what do you have to hit now? It equals. And when you do, yeah, you get 4.4297 equals r cubed. That's the same thing. That 0 is not a placeholder. Yep. Now, how do I get the r by itself? How do I undo cubing it? And the cube root symbol on your calculator, which this is the calculator you're going to use on the EOC, is the shift plus or minus sign. So r equals 0.7546. We're actually going to not round that. Why aren't we rounding it? Is that my answer? Was I looking for the radius? I was looking for the radius so I could solve for the what? And so what do I have to do with the radius first when I plug it in here? Square it. So actually I'm going to leave that number in my calculator. I'm going to hit the square button, which is the 3rd button in the top row. And you should get 5.69. And I'm going to hit times shift pi. It equals, and then I'm going to hit times 4. And you should get about 7.2. That's what you should see in your calculator with all those buttons hit. So the surface area for this thing would be about 7.2 and that would be meters squared. That's how much fabric they would have to go and get. Next one. I'm going to give you a little bit of time to try this one on your own. So that is a cylinder with a hemisphere on top of it. It is 3 meters tall and 2 meters wide. I want you to find the volume of that entire shape. So this is what we call a composite figure. It is a cylinder and a hemisphere combined. So if I find the volume of the cylinder, which you should know the formula for that, we've done that. You use the volume formula for a hemisphere, which I just gave you today. You find those two individually, add them together, and you'll have the volume of that full shape. Does that make sense? So go ahead. You have a couple minutes to go ahead and work on that quietly. What's the volume for a cylinder?
Pi r squared times height.
Okay, so it's base area times height, and then you even gave me the base area formula, which is pi r squared, correct? Everybody agree to that? Big B is the base area, which is a circle. So I got to find the area of the circle down there. That's what this formula is. Area of a circle. Are they going to give this to me on the EOC? Nope. All right, what's the radius of this circle down here? 1, not 2. That's probably a place where people could have made mistakes. So you should have had pi times 1 squared. 1 squared is 1. 1 times pi is going to be 3.14, but we're going to leave that all the way calculated out. So basically up here, we're going to do pi times what? It's right here. That's pi. Then a 1 squared. 1 squared is 1. 1 times pi is pi. So then pi times, what's the height of the cylinder? So in your calculator, you're going to hit 3 times pi. And what'd you get?
94.2.
9.42. That's the volume of what only?
That's the volume of the cylinder, which means the hemisphere, which we need to do some funny math. So what we do is we get plus.
Well, not yet. We're going to leave that number right there. So we're going to leave this number on our paper plate and we're going to write it down. And then we're going to find the volume of the hemisphere by itself. You with me, girls? So we're going to do 2/3. What was the formula? Pi r cubed. All right, what's our radius for this one? No. What's the radius of this thing? From here to here. So that's going to be the radius from here to here, which will be the radius for the sphere. So 1. So what's 1 cubed? 1. 1 times pi. Put it in your calculator. Then what can I do with this? Well, this is going to be 2/3 times some number that's in your calculator over 1, right? How do I do this then? Take that number, times it by 2, then divide by 3. That's how we multiply fractions. Top times top, bottom times bottom, and then just divide it. So you should have had 1 times pi, and times by 2, then divided by 3. And what'd you get for an answer?
2.09.
Now take those two numbers and add them together. And you should get about 11.5. And that would be meters cubed. That would be the volume of that, and that is called a composite figure. A composite figure is when you combine two figures together. So that's a cylinder and then a hemisphere combined together. Does that make sense? Yes or no? Last question, and then you're going to have some time to work on your IXLs, which go over this section. You guys ever seen how you get a, like if you went to the store and try to get a thing of tennis balls? They come in a cylinder, and there's 3 balls in there. Well, we're going to pretend like we have a cylinder and only has 1 tennis ball in it. So this is like the best tennis ball ever. It's $100. You only get 1 tennis ball. I know. It's actually a remote control tennis ball. So you can, I'm just kidding. So here we go. Exactly. It's got a gyroscope inside of it, so you can make it jump around and the other person misses it. All right, so we've got this cylinder. Yeah, he did that with a bowling ball. All right, so we've got a cylinder, and inside the cylinder, there's this tennis ball. And the tennis ball actually goes from top to bottom. So it touches the back side of the cylinder, the top, and the bottom. So that tennis ball is snug in this cylinder. I want you to find out how much volume is left inside the cylinder. So what am I going to do? I have to find the volume of the what first? Find the volume of the cylinder. Then find the volume of the sphere, yep. And then do what with the 2 volumes? Subtract them. Good, go. Oh, well, I guess I need to give you something, huh? The radius of the tennis ball is 12 centimeters. All right, so what we should do is find the volume of the cylinder. What is volume of the cylinder going to be? What's the formula? Volume equals what? Big B times H. It's been the same. We just did a cylinder just 2 seconds ago, right? What is the base formula for this circle? Pi r squared. So we're going to do pi. R is 12 squared. So that's going to be our big B. 12 squared in the calculator, hit that. It's 144. Then take 144 times it by pi. What do you get about? 452.16. Leave that number in your calculator. Every one of you should have this in your calculator right now. What did you use for pi?
Many times
You use the pi symbol, not 3.14? Okay. Did you use the pi symbol or 3.14?
3.14 because that's what I chose.
That it does. But on the EOC,
You actually want
I think you want to use the pi symbol. What did you get? 452 point what? So leave that number in your calculator. Do not get rid of it. Because what are we going to do with that number? That's the base area. What do we need to do with the base area? And we don't want to round until the very end. So we're going to keep that in there. We're going to times it by, what did we figure out our height to be? Well, if this is 12 from here to here, I know this radius is 12 and this radius is 12. And I told you that tennis balls touch the top and bottom and all the sides. So the height was also 12 or 24. Sorry. I don't know what I was thinking. So it is 24 because it's 2 12s. Times that by the number. So you're going to hit that number in your calculator times by 12. What'd you get?
10,851.84.
10,000. Sorry, I didn't keep up with you. What'd you say?
10,851.
Point
4, but that decimal's not going to be accurate because I use 1/4.
Peyton. What'd you guys get? 10,857. Peyton used 3.14 on his calculation. And Peyton, what did you get?
10,851.
So wait, right there. Do you see how far it's off? Because when the numbers get bigger, the more you round in the beginning. And he used 3.14. It's not like he changed the thousandths places of a decimal. Get it? Was the difference of 6 here. Okay? That's why I say use that. Unless they tell you on the EOC, use the pi button. Okay? On the IXLs, it does tell you to approximate using 3.14. So you do want to do that for the IXL. All right, now we got to find the volume of the sphere. Volume equals 4/3 pi r cubed. My r for this one is 12. So this is pretty straight. Forward as far as we're going to do r cubed. So we're going to do 12 cubed in our calculator.
12 cubed in the calculator because the fact there's no cube button. You have to hit the x with the y as a.
Yep. You can do that. There's a right next to the MR button. There's an X with a little Y. So you hit 12.
Oh, you use that little.
Then you hit that button and hit 3, and it does it for you.
It actually is a cube button, but you have to hit shift and that little triangle.
Okay. Does that make sense? The XY button makes it to any power you want. So you should have 1,728 in your calculator. That's this. Then you're going to hit times, shift, and then the pi button. Now you should have 5,428.67. Then we're going to times that by what? By 4. Good. You should have, what, 21,000? Then you're going to hit divide by 3. And you should get 7,238.229, whatever. And then you're going to subtract those two. And when you do that, you should get about an answer of 3,619.1 centimeters cubed. That's the volume. That's the volume that's left over for the tennis ball. Yeah.
It's like you could play bowling with the thing.
Does this make sense?
No,
All right.